Welcome to Web Handling. My name is Dave Roysum. I am very excited to introduce a new mini-series on human factors in web handling. Until the day that web machines run themselves, we will need to consider people in our machine design and machine operating choices. Let's get started. Your web machine is part of a system that also includes the web itself, as well as the people who operate the web machine. I will call this a man-machine-material system, at the risk of sounding sexist, because it is easy to remember. All elements must work together in harmony to have the best results. Web handlers are, or at least should be, strong on machine design mechanicals and controls. Product developers concern themselves with adding value to raw materials and to make finished properties that the customer might like. Management and operators have human concerns. Unfortunately, at the interface between arenas, we often have neglect, or opportunities depending on how you look at it. One example is product developers who do not always know web handling very well, or web handlers who do not know processes. This can create problems if, for example, a product developer desires properties or chooses materials that can give more trouble than necessary. This can cause extra waste and delay that can often be anticipated, if not avoided, by tiny tweaks to web product design. We addressed at least some of these concerns in a series of clips in the chapter Web201.46 and 48 series. There we listed several watch-out material properties. Another area of neglect may be the interface between operators and materials. For example, they may know from experience that some materials run better at different settings than others. However, it is very unlikely that an operator was taught that tension should be increased for stronger webs in proportion to MD tensile that is readily available from their test lab. We even have a simple guideline, such as the 5 to 25% rule. Yes, operators may eventually learn that stronger webs suggest higher tensions. However, operators could only learn that from experience, and only if they are allowed to play with the tension knob, to the point of causing waste. This literal trial and error approach to machine settings is slow and wasteful. Our focus in this mini-series will be another often neglected interface, the one between the man and the machine. The broad discipline that studies this is called ergonomics. In this series, we will focus mostly on a subset of ergonomics called human-machine interface, or HMI for short. Our goal is to make the mechanical and control aspects of the machine operation as intuitive, smooth, and safe as possible. So, why bother? The short answer is you can improve economics by attention to ergonomics. More specifically, you should see improved productivity, decreased waste, a happier workforce, and, last but not least, a safer and healthier operating crew. Please note that this course is not intended to cover the latest safety codes, which are in a continual state of flux and vary from organization to organization and from country to country. Rather, our goal is much more modest. That is, to note that sometimes by making machinery smoother to operate, it may also be safer to operate as a byproduct. We are greatly encouraged because attention to ergonomics may have little or no upfront costs. Let me give you an example. Arranging our controls from the same order and direction that the physical machine has costs no more than a random layout does, yet is far easier to learn and operate. Color coding costs little more than a bit of paint or a line of code in a PLC program. Before you start thinking, but of course, that's obvious, think again. We have many, many opportunities because we can be oblivious to the obvious. Let me illustrate the need with the poster child of poor controls, and that is for a modern TV. Here are the 4 remotes that are required to operate my TV system. There are collectively more than 100 buttons, and that doesn't count the submenus on the screen. My previous system had more, and a universal app that my son made for me was unreliable and unusable. Before you dismiss this example, I have on many occasions counted the knobs, meters, dials, etc. on machines. On simple rewinders, I have found that in most cases, the count is over 100. If you get to bigger machines, such as coders, printers, or laminators, the number of operator control points is much higher. To put this in perspective, a small rewinder has as many operating controls as a light aircraft, and a laminator may have as many as a jet aircraft. It is no wonder that our operators crash and burn, especially since they seldom have formal training. I will offer another familiar example to show that even reducing the control inputs does not always solve the problem. I am a road warrior and thus spend at least 100 nights in a hotel every year. In about 5% of the cases, I am totally unable to figure out how to set the hotel alarm, even though I have experience with hundreds of models. In other cases, I may make a subtle mistake, like not noticing the AM/PM light correctly on either the time or the alarm. Thus, to make sure I make my plane or to work on time, I also set my iPhone or other alarm for redundancy. This is a pretty straightforward task requiring less than 60 seconds, though the AM/PM thing is still a point of error. The solution to the AM/PM thing is quite easily solved by universally adopting the 24-hour clock, as do agencies that absolutely must get the time right, such as air traffic control, train schedulers, and so on. If I asked you, who are your customers? Almost all of you would say, well, duh, it's the people who buy our product. Well, yes, this is one customer, but not the only one. In my Web 101 class and elsewhere, I preach that we web handlers have 2 customers, the web and the operator. To the few occasions where I preach to machine designers, I say that they also have 2 customers, the web and the operator. Viewing the web as a customer very much dictates certain aspects of controls. Let us begin with the fundamentals. We must use engineering units instead of machine units. Thus, strength, tension, nip, and motor torque would all be expressed in kilonewtons per meter, not bar of cylinder pressure or amps of motor current, and certainly not percent. In the U.S. system, that would be pounds per inch, or PLI for short. Once we have the correct units, we can then discuss setting optimum values as well as how closely these values should be held. These were covered in great depth in our Web 101 class. However, as we began, this series is about the operator as the customer. Yes, having sensible control units, such as we just discussed, will help. However, we must do much, much more. we need to be concerned with the control interface, the area layout, and even the tasks the operator must do. This is the subject of this series. We will know when we got it right when the operator is productive, safe, and, as we will see, happy. Thank you so very much for watching this module in my Plant Practical video series. Stay tuned for the next clip where we will begin with the element that dictates much of the envelope of the control interface, the operator's chair.